Okay, so go ahead and list off the compounds.
Propane.
Okay, so we got propane. Propane is a C, C, C. H. Okay, propane.
And then dichloromethane.
Dichloromethane. So we got a Cl, a Cl, an H, and an H.
And a C.
And a C.
CH2Cl2.
Yep.
And one butene.
Okay, one butene. So that means that we got a C, put a double bond there, then the C, a C, and a C. So we got an H there, 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 and H there.
And isopropanol.
Isopropanol. So that means we got a C, a C, a C. We got an OH right there off the middle because it's iso. We got that, we got that. Okay, what's next?
CCl4.
Is that all?
Yeah.
Okay.
Can I guess?
Yes.
CCl4 will have the lowest boiling point.
No.
Oh, highest boiling point.
No.
Okay. Then never mind. I'm gonna shut
Okay.
up now.
So this is what we're going to do. First thing that determines boiling point. Oh, I forgot to log this. Is it 15? Okay. First thing that we use, intermolecular forces. Okay? Intermolecular force is going to be the first thing to determine whether something has a high boiling point. So let's go ahead and determine what's the highest form of intermolecular forces each one has. So with this guy right here, what's the highest intermolecular force that it will have? Propane.
You mean like different kind of bonds?
Like, will it have dispersion, dipole, or hydrogen bond?
Hydrogen bond.
This guy?
No. Dispersion.
Dispersion.
I knew it was one of those. I knew it wasn't dipole.
Okay, what about this guy? Dispersion, dipole, or hydrogen bond?
Dipole.
Dipole. Okay, this guy. Dispersion, dipole, or hydrogen bond?
Not hydrogen. So it's dipole.
It's not dipole.
Dispersion.
Because it doesn't have, it only has C and H bonds.
Oh.
In order for it to be a dipole, it needs to have at least something else. Okay, what about this guy? Got this nice little butte. Right
Now we
there.
got a dipole, right?
Oh, it's got more than a dipole.
But it has the H bond.
Yep. So this is a hydrogen bond. Okay, and what about this guy? CCl4. Dispersion or dipole? Or hydrogen bond?
Dipole.
Dipole.
Isn't like almost everything with a chlorine in it have a dipole?
Yep. Unless there was an O somewhere in there, then we could say it's dispersion. I mean, hydrogen bond. Okay, so right off the bat, which one has the strongest intermolecular force?
H bond.
This guy. So this is going to be our number one.
Highest boiling point?
Highest. Okay? Then we know that these two go together, and then these two go together. Okay?
So just curious though, which one is that? Is that the isopropanol?
Oh, this one? Yeah, this is isopropanol.
Okay.
Isopropanol. Okay. So this group being dispersion forces is probably going to be the last group that we need to worry about. And then we're going to work with these two. Okay, both of these dipole ones. Now this is where the second thing comes into effect. Mass. The heavier you are, the more energy you're going to require to get going. Okay, to separate. So this guy right here, this one, each chlorine has a mass of about 35, so we got 70, 70, so 140, 152 AMU roughly. Whereas up there we got 70, we got 12, so 82, 84 roughly. So which one's heavier?
Definitely
That guy.
the.
So this guy, he's second because he has a dipole and he's pretty massive. And then this guy is third because he has a dipole and he's also somewhat massive.
And that one is butene.
We got one butene.
Dichloromethane.
Yeah, that's dichloromethane. And then here, we got these guys.
So then we're still going off of mass right now, off of this, right?
No, now we're going, well, we're doing both. Now we're doing the
So-
dispersion and.
Right, because we
mass.
already determined the intermolecular forces, so then we go to the mass, correct? That's what I'm asking.
So both of them are dispersion, so they're the same there. And then we go to mass. So which one's more massive?
The bottom one, because there's an additional carbon.
Yeah, they have the same number of hydrogens, but this one has one more carbon. And with that carbon, we could actually see a shift, more of a dispersion shift. So this one actually has more dispersion potential than that guy up there. So this guy will be our number 4, and this guy will be our number 5.
And number 4 is butene. Or
It's one
Yeah.
butene.
One butene.
Butene, not butane. Butane would be if there was no double bond, but because it's butene, we put the double bond right there. If you take organic chemistry, you'll learn all about
But if you
that.
take away the double bond, because it's a single bond, would need an additional hydrogen.
You need 2 additional hydrogens. So you need one
Oh,
there
one
and
there.
one there.
Okay, cool.
Okay, so the
So-
second part of that question.
So it says identify the 3 true statements.
List them.
Dipole-dipole interactions are stronger than dispersion forces and hydrogen bonds, which is not
False.
true.
That's definitely false.
And boiling point generally increases the total number of electrons and molecules due to increasing strength of dispersion forces.
Definitely true.
Hydrogen bonds require carbon, hydrogen, and a halogen.
No,
False.
hydrogen bonds require just
Uh,
hydrogen, oxygen, fluorine, or nitrogen. No carbon is really needed.
This is
Hydrocarbons exhibit only dispersion forces.
Hydrocarbons?
Yeah, it doesn't.
That
it's
is
only the-
true.
Oh, yeah.
Hydrocarbons is just hydrogens and carbons.
Okay.
The only thing they can have is dispersion forces.
Then stronger intermolecular forces usually correlate with higher boiling points.
Very true. Hence why that guy has the highest boiling point, because he has the strongest intermolecular force.